Good afternoon. This is my Calgary web server Python project. So initially, I was doing this as it's the V1. Here, as this is a simple regex with encoding and decoding. But here I found out, here I found out we are totally getting 1829 skipped records. So as you can see in 4 and 5. Because of double quotes, these are not being recorded, and also some of the bytes and status codes are missing. So in my second iteration, I used the HTTP request and the version was missing. I used these. Let's go over this. We are importing pandas and regular expression, date and time, and the gzip and URL request. Here we are getting the URL file name, and this is the regex we are using. Here, this is host ident authorized user. Here's for the timestamp. This is a bit flexible request status request. This is status, and this is the bytes. Here in this line, here you can see that we are replacing unbalanced quotes with like missing double quotes and replacing them, fixing some errors. In this, you can see we are matching it with the original expression and trying to group them by these host, ident, auth user, timestamp, request, status, and bytes. And as I said before, there's like a few HTTP requests I'm missing. I've gone through I've gone through the entire records files. They were all HTTP 1. So if it does not exist, we are adding HTTP slash 1.0. Then we are splitting, which splits like splits it into a list of where it's the get post request on the file and the this request, the HTTP one. If the paths are empty or malformed, it defaults to slash, which is also a root directory. If the path is at least two elements, it takes the second elements as file name, removes everything after the question mark. As the file name switch, keeping only the in the index, we are splitting it by dot, so that dot html dot gif we are getting it over there. And also in the record, I saw that some statuses were either blank. If it's blank or not a digit, we are defaulting it to NA. Same for bytes as well. And the timestamp we are using, it's a normal default timestamp, and we are finally appending it to our past data. Then we are using it as a data frame. So here is a few examples. Here I would also like to show you the improvement we made. Using this particular, we are getting around 1641 malformed records compared to 1829. That's an improvement of around 10%. So here let's get into the questions. The first one is pretty simple. Here we are just length of the data frame. I have to execute it again. Here you can see 725098 records. And let's just run this. Yeah, it's 725098 records. The unique host is pretty simple. We are just, an unique function. There are just two hosts, which is remote and local. Then the third one, it's simple. We're just creating a formatted date and grouping them by date and counting unique file names. And we are also grouping it to the dictionary. Here we are getting the number of 404 responses. It's just counting the matching rows and returning the total number of not found requests. In the fifth question, they're asking 15 with 15 top file names with 404 requests. Here we are filtering the 404 status, and then we are counting the frequency of the top 15 matching names, and then we are returning it in as a list. Here it's very similar. We are also filtering it by 404 response code, and also top 15, filtering it by top 15, and then also returning it as a list. The seventh one, it's a bit big. we are copying the original data frame, and then we are checking if the timestamp is already in date format by using this function. If it is not, it converts it to datetime object using this. Then we are filtering it for the month and year, and then copying it to this using a lambda function and extracting in the DDMMMYY format. Then we are computing it by per day. The eighth one is almost identical, as we are also checking if the timestamp already exists. If not, we are using this function to make it into the proper format and using a and using hours value and sorting it by index. So you can see here the hourly count as a dictionary file. In the ninth one, it retrieves the file name from the data frame, counts how many times the file name appears, and selecting the top 10 and largest stuff. Yeah, and this is simple. We are just counting the number of HTTP responses and their consecutive count, and then returning it. Thank you.